Welcome. In this lecture, we shall be looking into the gas-liquid separation in the natural gas system, and this is the part 1 because there are several ways of separating the gas and liquid. So first, in these lectures, what we shall see the need of the gas-liquid separation, the various types of separation principles, then classification of the gas-liquid separators, the gravity separators, centrifugal separators, which will be covered in this particular lecture, and then factors affecting the selection of the separators and performance of the gas-liquid separators. So first, let us see the need of the gas-liquid separation. Why they are needed? To remove the solids, free liquid, entrained liquid in the gas and the entrained gas in the liquid. To protect the downstream equipment designed to handle a single phase. That means, if some equipment have been designed to handle single phase, then we cannot allow multi-phase system streams to go into those equipment. So we need to separate the gas and liquid, and because the natural gas, when it's coming out from the earth, it is also maybe trapping many liquids, many hydrocarbons with it in different phases, liquid phases, and some solids are also there. So we need to only take out the gaseous stream and not the other phases like solids or liquids. And this is used right after the gas is produced from the gas field. So here are some of the principles based on which these separators work. It could be momentum, gravity, filtration and centrifugal force. The momentum is the separation of two fluids with different densities if there is change in the flow direction. The lighter phase will turn faster than the heavier phase, thereby causing separation. So we effect some kind of a change in the direction of the flow. In the gravity, what happens? It is by their own weight the settling of the liquid droplets and solid particles out of the gas just due to the gravitational pull, and it works only if the downward gravitational pull is more than the drag by the particular fluid. The filtration is that we are using some kind of a porous barrier which will be having pore sizes that will allow some of the components which are smaller than the pore size to pass through it, and the bigger ones will be retained by the barrier. And then we have centrifugal force. In this case, what we do, we use the rotational action, and by this rotational action, what happens? The heavier particles and the denser particles will be moving away from the axis, whereas the lighter particles or the smaller particles will be moving towards the axis, and thereby we shall be able to separate the two phases. Here in this, we have this based on the gas to liquid ratio. We have different types of separators. One is high gas to liquid ratio and there is low gas to liquid ratio. Under this, we have the flare knockout drums, scrubbers, etc. And for low gas to liquid ratio, we have the oil gas separators and the flash tanks, etc. So there are various ways of separating them, and here we find that these are some of the various gas liquid separators. So today in our lecture, we shall be looking into gravity separator and the centrifugal separator. So first, let us go to the gravity separator. Now here we find that these are used to separate mixed phase streams into gas and liquid phases that are relatively free of each other. That means there will not be much of entrainment of each of the phases into the other. And here we are using the gravitational force. Then we find that if we lower the gas velocity, it increases the efficiency of the gas liquid separator because it gets more time for the particles to settle out of the gas. But it needs large vessels, and these are not generally designed to remove droplets smaller than 250 microns. So for higher size particles, these gravity separators are used. So here we find the typical components of the separator here. First, we have the primary gas liquid separation section. Here what we do, they remove the bulk of the liquid from the gas. So inlet gas comes, the inlet diverter. So from this diverter, what happens? The gas will tend to move up, and the liquid will tend to move down. So this is the primary bulk separator. Then gravity settling of the section, here we find that there will be in this zone, because depending on their density differences, we will finding different types of zones are being formed. Gas is lightest, so it will be staying at the top. If water the heaviest, then it will be staying at the bottom. And then we have mist extractor at the gas outlet. Here the mist extractor, this what is it doing? It is trying to reduce the entrained liquid to go out with the gas. So if any kind of oil is there with the gas, they will be retained by the mist extractor. And then we have pressure and level control valves to maintain the proper pressure and level inside the tank. This is a pressure and this is the level control valves for the various liquids. So all these things constitute a typical gravity separator. Under gravity separator also we have again more classifications. It could be vertical, it could be horizontal, or it could be spherical. So let us see the vertical separators. They are commonly used for low liquid to gas ratio, and they occupy less platform area, and that is why they are preferred in the offshore applications, and they have large vertical heights. And when we have large vertical heights, they prevent the revaporization of the liquid into the vapor and has gas flowing upward, and that is they oppose the flow of the liquid droplets by gravity, and size is bigger, thus costlier than the horizontal separator. So these are the typical features of the vertical separator. So here we show a two-phase vertical separator. Here we have the gas liquid mixture. So here the liquid is there. So here we find the gas is going and it is moving out from the top, and the liquid is coming out of the bottom. And in this we have the mist extraction, and in this zone, in the D zone, we have the liquid is separating by gravity, and this here we have the gas is getting separated from the liquid. So we have to give enough space for the gas and the liquid to get detached from each other. And then we have the three-phase separator. The things are similar, only thing is this: in this three-phase separator, we are able to separately take out the oil phase and the water phase in the two different vertical heights of the separator. Gas is still coming out from the top, and again we have the mist extractor. We have the chimney to take out any of the gas which may be going with the liquid, and here the downcomer through which the liquid goes into this section, and after going to a section, then what happens? It forms two layers, and this lighter layer will come out from this. So there is kind of sort of a baffle over here. It will be coming through this the upper section of the column, and here we have the two valves to control the level of the water and the oil, and here also we have the pressure control valve. After this, what we do, we go to the horizontal separator. These are favored for high liquid to gas ratio, unlike the vertical separators, and for the foaming liquids. They have more gas liquid interfacial area because they are horizontal. They are providing more gas liquid interfacial area, and they can accommodate lower gas flow rates, and that means they have higher residence time, and if the residence time is increasing, that means it will provide better liquid dropout. Then they provide large surface area. It means it is better for degassing and for more stable liquid level. They are easier to skid mount and stack, and they are used for heavy liquid loads where liquid loads are contained in the inlet stream. So for those cases, and generally because they are horizontal, they are favored more for the onshore applications, unlike offshore applications for the vertical separator. So here we have the two-phase horizontal separator. Again we find the inlet is coming here. Here it is the very large surface area, okay, and then this gas is going out through a mist extractor. Here we have the pressure control valve, and the liquid is coming out from the bottom, and we have the level control valve. and here we have a 3-phase separator. In this again we find the gas goes out from here and inlet is from this side. This is the inlet device and this is the gravity separation zone, and this is the mist extractor through which the gas flows out. And here we find that again we have a barrier, and this barrier is the oil rich layer, this is the water rich layer. The water rich layer will come through this and the oil rich layer will come from this side. So that is how we are able to separate the 3 phases in a horizontal separator. Next we come to the spherical separator, and these are used for high pressure services where liquid volume is low and compactness is required. As we know, for a given volume a sphere has the lowest surface area. So in this again we have a similar thing, that here we have the inlet and it is again gravity settling over here, we have the mist extracted over here, and what we find, the liquid is taken out from here and the gas moves up from the liquid and it comes through this particular downcomer and it is coming out from this spherical separator. And here we have the flow control device and the pressure control device. After learning about these gravity separators, we make a comparison in terms of the usage, capacity, cost, installation, maintenance, inspection and the separation efficiency. We find that the usage wise, that this is for the low gas oil ratio, horizontal for high gas oil ratio, spherical for medium gas oil ratio. Capacity wise, it can handle large fluid capacity, this can use large gas capacity, and it has least of all the capacity is least among the other separators. The cost wise, this is the most expensive is the spherical and least expensive is the horizontal. Installation wise, we find spherical is easiest and the most difficult is the vertical. Maintenance inspection wise, again vertical is the most difficult, and separation efficiency wise we find the horizontal gives the best efficiency, then comes vertical, and lastly comes the spherical. Now we come to these 2-phase and 3-phase gravity separators, and in this case we find this 2-phase separates the gas from the liquid stream, whereas in the 3-phase we are separating gas from the total liquid, and again the total liquid is getting separated into the oil and the water rich phases. And here we may have again classification based on the pressure. We may have low pressure units, medium pressure units and high pressure units. Depending on the pressure level, it is 10 to 180 psi, this is 230 to 700 psi, and this is 975 to 1500 psi. So we may have different ranges of pressure for this kind of gravity separators. Next we come to the comparison of the separators on the basis of droplet size. So we find that all the separators we are having, gravity separator, centrifugal separator, mist eliminator, and this L by G, this is the liquid gas coalescence. So we find as we move down this particular table, we find it becomes finer and finer droplets may be separated from by using different types of separators. So coarsest of them is gravity separator. Then these are some of the factors which affect the selection of the separators, like gas and liquid flow rates, the type of the natural gas indicated by the specific gravity, the specified quality of oil and water, then operating conditions, the presence of solid and available floor space. And these are the performance for the gas liquid separators. We find the separation efficiency is dictated by the droplet separation, which depends on the liquid and gas velocities. The entrainment means that any kind of liquid that is being trapped by the gas. So if there is too much of liquid entrainment by the gas, then we shall be losing the oil with the gas, and that is not desirable. Then foaming means if the liquid is foaming, what will happen, that it will trap quite a lot of gas. So gas will be going into the liquid, that we call the gas blow by, or the liquid may be going into the gas, we can call it the liquid carryover due to the foaming. and there could be waves generated at the gas liquid interface. Now we shall be looking into the centrifugal separator. So these kind of separators are used for gas liquid as well as for solid gas separation, and perhaps we are aware of such kind of separators which are commonly used for de-dusting the air in our day-to-day life. So these use the centrifugal action to separate the two materials at different densities and phases. They are more efficient and quite less susceptible to plugging. They are useful for gas streams with high amount of the solid particles. They can remove particles which are greater than about 100 microns in diameter and can have quite high efficiency for separation for droplet sizes as low as 10 micron, and are less commonly used because its performance is sensitive to small changes in the flow rate. So if there is not much change in the flow rate, they are quite effective. And these are the working principles: that we first pump the gas constantly into a cone shaped rotating container at an angle, and this creates a spinning vortex. And this, what happens then, due to the spinning of this thing, the high density liquids are pushed towards the wall of the cone, and whereas the lower density liquids are pushed towards the axis of the separator. And water is generally the denser component, so it will be going towards the wall and will be drained out from the bottom. And here we have a typical cyclone separator. Here we find this is the inlet, and the way it is introduced, it causes a vortex inside the particular separators, and due to this conical shape, what will happen, that this gets accelerated and the larger particles or denser particles are pushed towards the wall of the separator, and they are coming out from the bottom, whereas the lower density particles or the smaller particles are driven towards the axis, and then they also move out and they come out from the center of the axis, from the top. So this is the overall system on which these centrifugal separators are based, and these are the references which will give us some more detail about these various types of separators. Thank you.